One common challenge in manufacturing is scheduling jobs which need to be processed in multiple steps, say, machining followed by boring and threading. When there are two machines involved, Johnson's rule is the simplest solution, which we will discuss today. First, let us look at the problem in hand. We have 5 jobs from A to E, and their processing times on the two machines is given. On M1, we have a runtime of 28 hours, which means that the total time taken will be 28 plus the processing time on M2 for the last item made on M1. Let us assume that to be the smallest possible number from the table, which is 1. So the minimum overall time taken will be 28 plus 1, that is 29 hours. So when we assign the jobs on M1, we will do it progressively from 1 to 28, whereas when we assign jobs on M2, we will do it in reverse from 29 to 1 as shown in the table. As the first step, we look at the smallest duration activity across all jobs on both machines, and the lowest is the time taken on M2 for job A. We take it to the end of the queue. So it starts after 28 hours have elapsed and gets completed in an hour. That means the job can be processed at the end of the queue for M1, and it starts after 21 hours have elapsed. In the next step, we have 2 jobs, B on M1 and D on M2, which are both of the same duration. But since they are on different machines, there is no conflict. B becomes the first item in the queue for M1. D is second last in the queue for M2, just before A. In the third step, E is the smallest value still left, and since the minimum duration is on M1, it comes into the queue after B. That brings us to the last job, C, which is in the middle because the rest of the positions have been taken already. So the final sequence is BCDA, and the total time elapsed is 30 hours. Let us try an example of a similar nature. As earlier, we have 2 machines, 5 jobs, and the task to assign them in the optimal sequence. This time we expect the total time taken to be 36 hours, since 32 hours is the time taken to complete all the jobs on M1. The smallest duration on M2 is 4, so the minimum expected time is 36 hours. The sequence starts with C on M1. At the next step, there are 2 jobs A and B, both on M2, having the same duration. It does not matter from an overall time taken, which of A or B is done earlier. I prefer A at the end because A has the longer processing time on M1 as compared to B, but it is your choice. Similarly, we can do the next steps and arrive at C, E, D, B, and A as then the final sequence. This is all for today, but do write to us with problems that you may be encountering, and we will try and help you with solutions.